Good evening, everyone. How's the sound quality? Can you see me? Can you hear me? And is the quality fine? Okay, awesome. Right. So we'll be continue working on materials, and as I checked recently, some of you already submitted your assignment. That's really nice. Unfortunately, I didn't have a time to check it because literally I just went to my place from another university where um, I do classes on the side. Okay, yeah, so I'm about to share the screen and we can start working on things. Hmm. Okay, I will share the Windows system. Okay, I suppose you can see that. Can you see my Windows system? Great, great. Okay, okay. So, what we are gonna do? Um, we are gonna go through materials, but the only thing I'm thinking like, how can I share these materials here? Um, okay, give me a second. I will take them from the website, from the. Maybe I will do this a bit different. I will share the entire screen. Okay, I hope it will be much better. Okay, so yeah, so we finished literally on this thing on the assignment, right? So now we'll be going through if statements, and I suppose we will have a time to go through switch as well. Well, I really hope so. But anyways, we're starting with if. Okay, again, I have this problem with headers, but okay, it doesn't really matter. Okay, so the if statement, if construction, what's specific about that? Well, previously we tried to execute algorithms which work without any changes in the algorithm based on some conditions. For example, if user typed one thing, we would run one computation. If user typed another thing, we would run another computation. But now we will overlook so-called if statements. Firstly, uh, so what statement is about? So if I would try to refer to the block scheme, sometimes we call that as the flowchart, it would be such case. I'm more than sure that you know what flowcharts are. So we have the algorithm reaching the condition, and condition can be correct or can be not correct. Sometimes we call it as condition can be true or condition can be false. So if condition is true, so we run instructions. If condition is incorrect, then we are not running instructions. And this case could be done quite simple. So what we'll be using? We'll be using such construction, such syntax is better to say. So we'll be writing if, then we'll be placing a regular bracket, and within them we'll give some equation which result can be convertible to Boolean value. Okay, so what's the Boolean value is? So actually it's logical variable, it's logical value, which can have only two values. One of them is true, another of them is false. If we would try to talk about conversions of this Boolean value, so to Boolean values, conversions leads from a zero. It's related to numbers, and all the rest gives us true. In the same time, if we would like to make some connection between texts uh, and Boolean values, so empty text, text without any symbols, can be represented as Boolean value false, and all the rest cases go for the Boolean value true. So if it's not really clear what I'm talking about, so after some time you will get the idea. Anyways, we are starting with this construction, so we can write if, we can write in conditional brackets, and then we're supposed to give an entity, and this entity can be an operator. If we're about to run only one operator or one instruction when condition is correct, or we can give a few of them. But if we are given few of them, we have to merge them into one block. And we are merging instructions into blocks using curly brackets. So in the multi-operator case, we're given the block of operators as the entity which has to be provided after if condition part. Okay, let's see how that works. So what do we have here? Okay, here we have the following equation: a divided by b. So here we are using the input type of standard library, which assumes printf, scanf. I don't really remember which one you're using mostly, but actually there are two approaches for inputs outputs. One is printf, scanf. Another is cout, cin. So here we're using exactly standard input library. So we're using printf to print information and scanf to read information. Well, the scanf assumes that we have to have the template of the data which we are receiving from the keyboard when user presses enter. And literally the percentage sign here means the beginning of the template. And F means that we are receiving the floating point value. So the second argument is a reference. And how do we get it as the reference? We have n sign, and then we have a variable. So literally, scanf function is well, can change value in the variable a, and can read exactly the floating point information. The same happens for b variable. So we're printing out text b equal, then there is cursor stance and flickering, and then we type some value, we press enter, and that value goes to variable b. Okay, in what cases it's impossible to run this equation? Well, in one case when b is equal to a 0. Well, some people tend to say that it's possible to do that, but the result will be infinity. Well, might happen, but as we know in IT, such operation is exceptional. It's always exceptional. So we have to check if it's possible for us to run it. If it's not equal to a 0, so exclamation sign and equal means not equal. Okay, so if b is not equal to a 0, then we are running this instruction block, within which we are calculating a divided by b, and we write the result in variable y. So here we have it. And then we're printing the result on the screen. And what do we have here? Here we have an interesting template. So we have 4 and 2. So there could be the question, well, what does it mean? So if we have the floating point, or actually any template that involves point in it, we can literally specify two values. Uh, one come before the point, another after the point. The value before the point says how many symbols on the screen, because it's the output, right? And the template for output. How many symbols of the screen they will be using for this number, which will be given to this template to be printed. And the value after the point says how many symbols from the overall, so from these 4 symbols, will be used for the fraction. Well, 2 symbols. And fraction means a part of the number on the right side of the dot. Okay, and then we printing stuff out. So like programs end, and that's it. Now, the only thing that this code was compiled in Borland. So if you're using Linux versions of compilers, so you have to take out maybe this line and a getch line, and everything should be working well. Oh, oops! Somehow I didn't. Yeah, I didn't translate that because it's some compilation of materials. Sorry for that. Okay, here we have the same case, but we are using input-output streaming library. And here, literally, the program is the same, but the input and output here is implemented a bit differently. So here we're using cout. So cout, and then we can give as many blocks of this begin of printing, like less, which means portion of the printing, and then printable data itself. We can literally, you know, we can literally repeat this part several times. Okay, and then by the scene, we are writing a value from a keyboard to variable a. And once again, here we have this comment defined in such way scene, and then portions of data which are gonna be received from keyboard, and those portions start with greater signs. The same happens for b variable, and then again we check if b is not equal to 0, and if it's not so, then what we do, we calculate value and we print the value out. Well, as you probably see, here we don't have any templates for receiving information, printing out information. So it means that data which we expect to have in the output, in the terminal's output, literally um, literally cannot be predicted. Like you see, we have 2,5, right? But we cannot really say that we would like to have 2,50 instead of what we have here. Um, well, actually, there are a few tricks how to do that, but it's not something that can be just written within a cout easily. I mean, without some additional comment, or let's call it, in a way it has to be working all the time. Okay, are we fine so far? Is everything great for us? Okay, I really hope there are no any single question about this, because it's super simple. Okay, the if else case. Well, literally the story is the same as with the previous if. The only difference is that we are capable to have the branch of the incorrect conditions. So after the operator, after, or let's call it after the entity of the true branch of if condition, we can write else, and we can give an entity of the operators or instructions for the case when the condition is not correct. And again, it could be an operator or it could be a set of operators. And the line where we have the cells doesn't really matter. So it could be on the same line where we end true branch entity, or it could be on the next line or after a few lines. That really doesn't make any difference. Okay, so how would it look like in the form of the flowchart? So we have instructions for the case when condition is correct, and in the same time we have operator for the case when condition is incorrect. And again, let's take a look on example. So what do we have here? Here we have the same case as previously, a divided by b. And we have the if statement, and we have um, condition b is not equal to 0. Then, as we know, we are capable to make computations. Otherwise, so the else case, we are given a text out, so everyone could see that well there is the problem, so we cannot really divide by 0. Okay, let's see how that works. So I will copy this and I will place it in the empty file. So I will be using this C++. Okay, so as you can see, I um um wait a bit, please. Oh yeah. Um well guys, um I will have to leave you for some 5 minutes, unfortunately. Sorry for that. So in some 5 minutes I will be back. Because there's unexpected visitors. Okay, so just wait for me, guys. Okay, so I'm back. Yeah, sometimes issues happen, but what can expect? Okay, so back to our codes. Yeah, so we have a devcpp. Maybe you're using some another compiler, so that's really up to you. Here we have the true branch of the if statement. Here we have the false branch, and we can literally run this app by pressing compile. Okay, we'll need to save it somewhere. Yeah. So let's type values, for example, 10 for A, 2 for B. Okay, so we see things made correctly. That's great. Now we are gonna give another values. For example, same 10 for A, and let's say it will be 0 for B. So what do we get? Dividing by 0 is not possible. So that's the idea. Well, I suppose it's super easy. But there could be several questions. Okay, we can make conditions, but what exactly symbols and syntaxes can we use? So, if we have two numbers, like here, of variable of which values we are receiving, or whatever, maybe equation written in brackets, we can make comparisons between them using several operators. Operator equal, not equal, smaller, greater, smaller or equal, greater or equal. And sometimes we're about to make combined conditions. So what are those combined conditions? For example, you're about to run one condition in one if statement. So you will need to combine them. How you can combine them? Well, you can use several logical. Well, yeah, maybe we can call them as the logical operators: operator and operator or. So um, operator AND has higher priority than operator OR. But anyways, I would like to recommend you guys always use brackets when to split conditions which you are combining using operator and operator OR. Uh, so I'm more than sure that you had already some classes related to logic, but anyways, let's maybe try to remember how these things work. Maybe I will use the Excel, and we will be using let's say value A, value B, and A and B. In the same time, we'll be using A or B. A and B, A or B. Okay, so we will have this things, and we can give possible values. So as you understand, the result of condition, right, is always the Boolean value. So Boolean values can be only two values, false, true. So if we have two variables, let's say of the Boolean values, because we make an assumption that A and B are conditions which we're about to combine using logical and logical or operators, so they can be only such varieties of values. And there is no any single other variety. Because you know, two possible values per two variables is 2 in the power of 2, so overall 4 combinations. Okay, and logical AND works. Well, maybe first I will define you the simplest definition of that, and then the real definition. Same as for the operator OR. So simple definition says if both of values are true, then result in true. In all opposite cases, it's equal to false. Which means that this is false, this is false, this is false, and this is true. And logical or simplistic definition says that if one of values is true, if at least one of values is true, the result is true. In all other cases, the result is false, which means that here we have false, here we have true, true, and true. Okay, so why did I say that these are simplistic definitions? Because they are kind of rule definitions of logical or and logical and they sound in a following manner. So logical operator or if we have a chain of logical um, operations or like this one um, gives going from the left to the right side gives the first value which is convertible to true or the last one if none of such found. Literally, that's the real definition of logical OR. And what's about? Oh, and maybe we have to maybe think about some example. Let's say we have. Let's say we have 5 or no, better example. 5 or empty text or 5 or false. The result will be 5 because 0 is convertible to false, empty text is convertible to false, 5 is convertible to true, so 5 will be the result of such equation. Surely, if we are working only on true and falses, then the result will be true, you know. But that's the real definition of logical OR. In a similar case, if we would have a definition of logical AND, for example, it could be something like this. So its definition is that in the chain of operations AND, we receive the first value which is convertible to false or the last one if none of such found. So if we would have a chain of AND operations like the following, um, let's say false. So the such equation will be a 0 because 7 is convertible to true, user is convertible to true because it's text with something, and the 0 is convertible to false. Okay, anyways, these rule definitions of or and it might happen that they sound a bit complicated, but you have to know that such equations actually they really exist in IT, and they're used pretty frequently. So it will be just good for you to know that such definitions exist. Okay, is there anyone who already knew such definitions of or and? Oh, okay. Okay, great. So you know how to deal with truth tables, right? Great. Really great. Okay, so let's continue working on things. Okay, so there's a specific libraries available in most of C language implementations. So those standard library and the mathematical library. Well, these libraries contain a lot of really necessary functions, and sometimes even some constants like p value, and we can use them in computations. For example, so we have a necessity of, let's say, calculating values power. So value um, in some power. Okay, that's great. So how can we do that? Well, what do we do? We are adding a mathematical library to the code, so we're using math.h. Um, and then, oh, and by the way, here we have just our stream, and there could be the question. Okay, in some cases we have .h, in some cases we don't have .h. Well, actually, it really depends on implementation of language, because 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 literally names which you mentioned here, they are exact names of files that contain the codes which are located on the hard drive, and those files come from installation of compiler. So it's not really up to us to choose if we are using .h or we are not using .h. We just have to do that in the same manner as we have files in our system. That's the thing. Okay, so anyways, math library is attached, and now what we can do? We can use the storing function, which literally powers the first argument in the power of the second argument. So it will be a in the power of x. Let's maybe take this code and try to apply that. Okay, so we have it, and now we'll compile and run it. So let's suppose we'll be running 5 in the power of 3. So literally we know that the result will be 125, and let's see if it's really so. Okay, so 5 to the power of 3 equal to 125. So as you can see, we have it. Okay, great. Well, I suppose this thing is super simple. Okay, here I have just a small description of what actually is that power, but I suppose that you know what is the base of the number, what is the exponential part. So I suppose we don't really need to make any simple math things. Okay, so I suppose we are fine so far. And I think that could be a good case to try to apply things. So here I have a couple of tasks. I suppose um, it's pretty simple to make them. So the first one, so write a program that calculates and outputs the square root of number on the screen. So user types number and you give a square root. Then the number entered by user, if the user enters the negative number, the program prints on the screen notification that the square root is that the square root of negative number cannot be calculated. So guys, let's start with this task. So in a lot of places it's mentioned draw the flowchart, but let's ignore that. So guys, it's kind of class task, so please start doing that. Um, and once you did that, maybe you can publish your codes, which shows how you did that. Or if you don't really like, you can just type that you've done that. It's quite enough. So are we good to start class tasks? Put a plus if you're ready. Okay, so please try to make one. Okay, I will maybe put this definition into chat because I cannot really simultaneously see both chat and its definitions. Not to mention Windows system because right now I'm working from just one screen. Oh, well, as I said, you don't really need to use the flowchart, so you don't really need to do that. Just an application, just a C language application. Okay, and about the condition itself. Well, if your user types the value, right, he or she can type value in the negative form, like a minus 7, minus 15, minus 66, or something like that. And you cannot really get the square root without imaginary numbers, from the negative number. So, before starting to receive the square root from the number, you have to be sure it's not negative. And when it is negative, then you have to just tell user, well, your number is negative. I'm not gonna make the square. So if variable is a, for example, then the condition will be if a is bigger or equal to the zero. Probably that would be the condition. Okay, Nikita, I really hope I managed to answer your question. Okay, if any other questions, don't be shy to ask. And it's not mandatory to only write if you have microphone, and if it's easier for you just to tell the question, you can always welcome to activate the microphone and just tell your questions. So do we have anyone close to the end of the app? Okay, so let me know when you will finish. Okay, great. Okay, so let's hope some other colleagues will make it the same fast. All right. So so since you are done with it, I suppose you can take a look on the next one. So the second task is to write the program that compares the digits of the double-digit number entered by the user and prints on the screen if the value of monotone. So first and second digits the same. Ascending, first is smaller than second, or the scadden, when the first is the bigger than the second. So user types the whole two-digit number, and you have to say which number is it. One of these three types. So for students, you can start doing second task. So is there anyone else who is close to the end of the first task? Oh yeah. So guys, please don't forget to write about your progress. Otherwise, I'm like thinking, okay, maybe others didn't make the first one. So just to be sure that I know this. Okay, so anyway, since the first one is done, so again, the second task asks from the user to type two-digit number, and then we say if it's monotonous, so two digits are same. If it's a cadence, so it kind of goes up. So first is smaller than second one, or it's the cadence. So first digit is bigger than second digit. Окей. Так, ну там задание такое. Ам, ам, Значит, у нас двузначное число, и нам нужно сказать, какие там цифры. Это монотонные, значит, они одинаковые. Или же у нас цифры восходящие идут, то есть по возрастанию, сначала маленькое, потом большое, или по убыванию, сначала большое, потом маленькое. Ну вот как-то так эта формулировка звучит на русском языке. So there could be the question how to separate decimals and just ones. So you can always divide the number with 10, and you can literally assign the result to integer, and you will receive just decimals of your value of your number, and then you can just compare these numbers between themselves using if and else statements. Is there any progress with the second task? Okay, okay, take your time. Okay, so I see that a second task is done um um for Carolis. Okay. So the third will be the following one. So write the program that asks the user to enter three straight edge lengths and determine whether they construct a triangle. Um, in this case, you have to know that each side of triangle is less than the sum of other two edges. Actually, this task is kind of simple. But you have to go through all of varieties. I mean, you have to check um, all of those sites. And once again, guys, since your colleague finished the second task, it doesn't mean that you don't have to inform that you finished that. Please keep this in mind. Okay, the question from Никита. Ага, на втором надо использовать три раза. Ну, ну, можно и два использовать, просто вы сначала сравните два значения, если они одинаково вы выводите, соответственно, что у вас монотонная она, ну, монотонное число, а если нет, тогда у вас второй if пойдет с else, с false branch. То есть посмотрите, если первое число меньше второго, тогда у вас восходящее, но в противном случае нисходящее. Ну, то есть в первом аскединг, а во втором дискединг. Exactly. That's why we take a look not only for the cases when if has the true branch, but even cases when we have true branch and false branch. For those who didn't get the question, the answer, so Nikita asked if we have to use if three times in second task, and it's absolutely no. We can be in love with two of them. So the first would, for example, find if number is monotonous. If it's not, then we can use another if. Let's say if first number is less than the second, then we have a scaling number. Otherwise means in the opposite case, it will be the scaling. So two ifs are enough. Oh, great, great. Um, okay, so if you think that third task is done, so what you can do, you can make the last one, and it's just a regular computation of second order equation. Sometimes we call that as quadratic equation. It's like x squared plus something equal to a zero. And we can have three cases. The first of all, we calculate d, so discriminant, and then based on its value, if it's zero, if it's less than zero, if it's bigger than zero, we show that there are no roots, so no solutions. There is one solution, or there are two solutions. And as you remember, guys, from the math, well, I assume that you remember because there was no any single question about the square root. So square root is something. Well, for example, square root of is d in the power of 1/2. Or you can use sqrt function for the square rooting. Okay, so Lavrinus made the second task super. So since the second is done, so please make a solution for the third one. So you're entering three straight edge lengths, and you find out if you can build a triangle. And here we have the conditions. So each side of triangle is less than the summation of two other edges or two other sides. So please start making this task. Wait a bit, please. Okay, so also let's make the third task. Great. So now you can so now you can make this one, the task number 4 related to a quadratic equation solution. Okay, Carol has made the the last task. Um, okay, okay. Actually, there is no other tasks assumed. Okay, maybe you can send your code to take a look if everything correct related to the last task. Well, you don't really need to comment the code because the code will be pretty simple because the algorithm is quite simple anyways. Okay, so linear equation, good. Then discriminant computation, okay, great. Then d is bigger than a zero, then yes. Um, the only problematic is that when you have d bigger than zero, then you're given two equations. But remember, you're given an entity, right, which can be one equation or a set of equations. And if you're given set of equations, so you have to use curly brackets, and your equation should be between curly brackets. So I will copy your code in my editor, and I will show what I exactly think. Um, so here you have a kind of one equation and two equations, right? So you have to put them in between of curly brackets like this. So exactly this is what I mean. Okay, okay. So let's have another 5 minutes because I was out for some minutes. So anyways, let's maybe wait, maybe there will be some questions. Okay, do we have any progress? Okay, yes, yes. This thing can take some time because everything needs practice and you need just to know just keep working and trying and after each next try things will become more and more easier. Right. Well, I think we can finish. Do we have any questions in the end? Maybe something's not really clear. Might be. Okay, looks like no questions because nothing is written in the chat. Okay, guys. Okay, so we're about to finish then. All right. So thanks for being connected. Really appreciate that, and hope to see you in the amount not less than today. Okay, guys. So have a nice evening. See you next time. Bye bye, guys.